Hello class, welcome to the video. I thought I had my first screen ready to go, and it turns out I don't. Here we go. Okay, hello snowflakes. How are you? I hope you did great on your quiz. And as a reward for such a good job, you have this nice little video to watch tonight. Here's our agenda. First, we're going to check your answers to the chain rule. That was the worksheet. By the way, please read the worksheet and do the chain rule problems. If you get stuck on the chain rule problems, that's totally fine. Being a chain rule expert actually isn't essential to do well in this unit. It just kind of helps with the introduction. The thing we're going to do after we check our homework is learn our metaphor for this unit. Tomorrow's pop quiz is more about did you watch the video, prove it by describing the metaphor. Don't really worry about doing the math too much. We're going to do some practice problems for U substitution. In other words, we're going to take the chain rule and do it backwards. We are going to take your answers to the chain rule problem. We're going to make those questions, and then your questions to the chain rule problem, those become the answers, because we're going to be doing antiderivatives. We're going to be reversing things. Our practice part 2 is actually that question that's going to be on the quiz. If you did the reading before the chain rule, I actually give you a preview question for the next quiz. And we're going to work out that problem. So that's kind of one quiz question that no matter what, you should be ready to ace. And then we're going to say goodbye. All right, and look, I know for a fact that if I drag, this video will be like 35, 40 minutes. So I am really going to try to fly from here on out just to keep it under the 20, 25 minute mark. We'll see how it goes. In our homework, I will simplify, and that just is just for the antiderivative steps. I want them to look a certain way. I know I forgot to put dy dx in the instructions. It just says g prime. So we're looking at cosine. Derivative of cosine is negative sine. Remember, in chain rule, you don't mess with the inside. Instead, you chain on to the end of the problem the derivative of the inside. So that should have been our first one. I'm going to simplify this as typos. I'm going to simplify this as negative 4x cubed sine of x to the fourth. G prime for this one. So once again, we're starting with what's on the outside. So the 45th is on the outside. Our power rule for derivatives says bring down that 45, make your new exponent a 44. And then chain rule tells us to chain on the derivative of the inside. Now for that simplify step that I talked about, I will simplify. I'm going to multiply the front and the back together to make it not 320, just kidding, 360, 8x plus 1 to the 44. And like I said, these, I think the simplification is obvious. The next couple, it just has to do with what I want to do at the end of the video. All right, down comes the 5. Remember, coefficients just hang out. So let's call this 5 over 15 x cubed plus 3x squared plus 1 to the fourth, because we're doing the power rule for derivatives, so our exponent goes down. And then our chain rule step, that inside expression, we differentiate and chain that to the end. I know that should be a plus. I know. Plus 6x. And remember, derivative of 1 is 0, so we can kind of stop there. Now, this is 1/3, right? We can really just call this 1/3. You cannot distribute 1/3 to the first polynomial because this 4 is like blocking it. You can only just distribute basic multiplication for things that are degree 1. So really, let's take 1/3 and distribute all the way to the end of the expression, which actually works out nicely, right? 1/3 of 3x squared is x squared. 1/3 of 6x is 2x. Still need parentheses for that group. Let's squeeze in an equals here to show we're like on to our next step. And then remember, it's multiplication, so the order you write it out doesn't matter. So let's put our degree 4 factor at the end. Hey, by the way, remember, you always have the power to pause and you have the power to rewind. So look, I'm cleaning the screen right here, but you hit pause if you still kind of need to soak up how my final answer came to be. 3, 2, 1, go. All right. And let's do D last. So remember, 5 is a coefficient. 5 is just going to chill. E to the power is e to the power. Remember, e to the x is e to the x for derivatives. And then now we apply the chain rule. We look at our inside expression and chain on the derivative of that, which is 1/5 cosine of x, right? This factor is the derivative of this exponent. We're doing our chain rule. Now this one, the simplification is pretty obvious. 5 and 1/5 cancel out. Let's put cosine out front. It gives it a nice look. And then let's also just rewrite it because my handwriting is so bad. And then, you know what? I'm kind of feeling the parentheses. I really like parentheses around the angle in a trigonometric expression. I'm just never consistent when I'm writing and working because I'm thinking about a lot of things. All right, so these should have been your 4 derivatives. In other words, what we're going to do is we're going to take these and make them the question. The answer will become the question, and we're going to think, what's the antiderivative of this? And we should work ourselves back to here. Before we do that, we need to talk about our metaphor for the pop quiz. So let's look at our scenario. Imagine a friend calls you to help them move across town. They would like you to put things from their bedroom onto the truck. Let's look at some of the possibilities for the bedroom before you arrive, right? If someone says, hey, can you help me move? The questions are first like, how long? Or how much? You know? Or sometimes, how many other people? So let's look at some possibilities for the bedroom, and we'll decide how easy it is going to be to move. All right. Possibility number 1, and this is actually, this is kind of the metaphor for a question on our test today. Am I red? I should be red. I think you had 0 to pi 2 cosine x dx. This question was pretty simple. It was kind of ready to go. Much like this room. If you walked into this room, you would just pick up this dresser, carry it to the truck, or you and your friend together would grab this bed with both hands and carry it to the truck, come back, get that dresser, carry it to the truck. You could just kind of walk in and get to it and move the bedroom. And that's kind of what was going on in this integral. You can just kind of look at it, write down the antiderivative, plug in the stuff, and get an answer. Let's look at a different possibility, a much more realistic possibility based on who your friends are. You walk in and this is what you see. I don't think it makes sense to just grab stuff and carry it to the truck, right? You could just grab this shoe, come back and grab this shoe, come back and grab the lamp. But this is really ineffective. This is just too much of a mess to start moving. So before we move, right, before we actually do, honestly, like this U substitution, what we're going to do isn't technically calculus. No, I take that back. It is. I misspoke. I was going to say actually it's all like pre-calculus stuff to make our life easier, but that's false. All right, pretend I didn't say that. What you would do, hey, you're going to take all this stuff, you're going to put it in boxes. Let's go back. Before, right, this is challenging to move, but if you put it all in boxes, it becomes easy to move. Suddenly we can just do what we want to do, which is grab something, pick it up, carry it to the truck, drive it across town. All right, so that's going to be our metaphor. Remember for the quiz, helping your friend move by packing their messy stuff into boxes. That's our metaphor for this unit. Okay. Now let me do a quick little talk here. U substitution is all we're learning, and it's kind of complicated. So if it does not make sense perfectly on day 1, that's okay. If it doesn't make sense perfectly on day 2, that's okay. If on day 3 you still find it pretty challenging, that's okay. If I thought this only took 1 day to learn, we would have a quiz tomorrow. I would just say, watch the video, and then I'd give you the quiz, and you'd be good to go. I think it takes 3, 4, 5 days to get used to it. So what I really want you to do is not ask yourself, do I know what's happening? It's, do I understand this topic better every day? right? Just think about making progress. Don't worry too much about, I don't get it from the beginning. All right, that's my little speech. And that just comes from experience of kids feeling very scared because the first time they see a problem, they don't understand every step. And what I've learned is practice makes perfect and the fear starts to go away. So you're allowed to be confused. That's fine. Just know that that's normal. And I'm here to help. All right, let's go to our first question. Here we go. And now let me give you a chance to look at this. You might know the answer to this because you look at this and you recognize this was your answer on the first page. So down here, we're expecting something like cosine x to the fourth plus c, right? If we took the derivative of this, we would get the integrand. We're going to reverse that process. First thing we're going to do is look at this problem and talk about these two blanks, a and a prime. These are kind of the clues that this is u substitution to begin with. In other words, when you look at an integral, you need to think, what technique am I going to use? The decision to use u substitution comes from looking at individual factors and deciding, do these factors have an a and a prime relationship? Now, for example, is negative 4x cubed, if that's your a, is x to the fourth your a prime? Does that make sense? The derivative of this is this? No. That is no good. Instead, we ask ourselves the question, hey, does it make sense that x to the fourth is the a and negative 4x cubed is the a prime? And the answer is not exactly, but man, it's a lot closer. And obviously, we could kind of take out the negative, but let's leave it in for the moment. So we look at these two terms, and they have an a prime feel. It's not a perfect match. But hey, to the fourth, the derivative is to the third. So kind of fitting this relationship means this is a u substitution problem. So we are going to put our metaphor to work. We're going to take this problem, and we're going to get some boxes. Let's do one box to pack some stuff into. And down here, we're going to have another box. This is another kind of, we're going to take parts of the problem and pack them into these boxes. Now, our first box is called u. And this is where the phrase u substitution comes from. U is a box. What goes in the box is your a. So in other words, u, a, those are the same thing. We look at x to the fourth. We look at whatever could be the original, not the derivative, but the original. And that's going to go in our first box. So u equals x to the fourth. Now our second box is going to be a substitution for dx. So we don't have any dx's here. So let's kind of, let's rearrange some things. Let's look at our expression and take our derivatives. Derivative of x to the fourth is 4x cubed. The derivative of u, we could call it u prime, but that's not very helpful. It's true, but it's a dead end. So we're going to use some different derivative notation. We're going to use our du dx notation. So instead of like y and x and dy dx, we got u and x, so we have du dx. Now we're going to cross multiply and solve. And by the way, there's no reason a student would sit down and know to do these steps. You're only going to know to do these steps because I'm telling you to do these steps. The only reason I know how to do these steps is my teacher told me. They said, hey, pick a u, then take its derivative, write it like this. I said, yes, Mr. Mansfield, and here we are. Okay, so if we cross multiply, we're going to get 4x cubed dx on one side, and we're going to get du on the other. And then what we're going to do is divide by 4x cubed on both sides, and that's going to complete our second box. Dx equals 4x cubed over du. So these kind of are two boxes. And this is just what you're going to learn to try to achieve. To think of what's my u and write it down. Take the derivative and cross multiply to determine what's my dx. What are my two boxes? Because what we're going to do now is take this problem and we're going to rewrite it. We're going to pack some terms into boxes. So for the moment, we're keeping negative 4x cubed. But instead of x to the fourth, we're going to pack that into a box called u. And instead of dx, we're going to, I don't know if pack makes sense because it's more, not less, but we're going to substitute, right? Let's just use a regular math word. We are going to substitute for dx this expression. I have made a mistake. I'm so sorry, y'all. You're probably wondering, Mr. Maltzby, when you divide by 4x cubed, shouldn't 4x cubed be on the bottom? Yes, it should. Okay. I would stop and re-record the whole video, but we're not going there. All right, coming back to here. Sorry about that. So yeah, substituting for dx. This time we cross-multiplied and solved correctly. And the reason I realized I made a mistake is what's going to happen so much is you're going to get some factors that divide out to 1. So let's look at this problem. Now we got the integral of negative sine of u du. If we just look at our original problem and where we are now, I mean, look how much more organized our integral is. Here we had just kind of more of a mess, right? There was clothing all over the floor. Now we've packed it all into a box. And look, the letter change just means we got to change our letters. So instead of saying antiderivative of negative sine x, we're just asking antiderivative of negative sine u. The antiderivative for negative sine u is positive cosine u plus c. And then if we look, hey, u is equal to x to the 4th. So we're going to take out our u, put x to the 4th back in, and we're done. We have found the antiderivative of this expression. Now, the antiderivatives in this unit, they are harder. On the quiz, you just looked at it and you wrote it down. Now you got to look at it and determine a strategy to work towards the antiderivative. Right? That is the challenge. And it's just going to come from mastering this process of starting with, okay, do I have two factors that have an A prime feel? If so, let me make the a the u, take the derivative, find the dx, go back, reorganize the problem. All of this work that we did was to jump down to here and make an easier question. So we're going to work through a couple of more. I don't know that we'll do all the ones from the homework. It just depends on the time. I don't want to make you watch too much at home. All right, so let's just jump to this one right here. So this was our second question, and this was our answer. So once again, now, in this unit, everything is u substitution, so you automatically know you're going to use u substitution. But the reason I would know is I see 8x and I see 360, and I realize, okay, the derivative of 8x plus 1 is 8. 360 isn't 8, but it's a multiple of 8. So in other words, the derivative of a linear is a constant, right? 360 is really, I believe, I think 8 times 45, right? So just that, oh yeah, if you take the derivative of this, you get a multiple of 360, right? Derivative of a linear is a constant. So that's how we know this is a u substitution problem. So if this is a u substitution problem, let's do our first box. Remember, our first box comes from, hey, okay, what is the original, right? What's the higher degree term? We make that our u. Let me fix that for you, please.